in search of soil.
For a lot of the fungi that pair up with plants, do you have any sense of how much of the carbon that makes them up is coming from the plants? Like, are they 100% dependent upon those plants to survive? That's where they're getting the carbon, or can they synthesize that themselves from other organic matter in the soil?
Well, the rule of thumb when you get introduced to mycorrhizal fungi, we can start there. The endophytic fungi that live inside of plants, there's just lots of questions around how they operate and a lot of the nutrient exchange. Big questions there. So I can't say so much about those fungi, although I do imagine certainly they're getting tons of their carbon. I mean, that's essentially their host that's feeding them, and then they provide a lot of effects and compounds to the plant as an exchange. So I'd imagine. I can't imagine where else they'd be getting their food, actually. I mean, they're getting probably all of it from their plant host in large part. But as far as the mycorrhizal fungi go, they are much more conclusively studied and much more directly studied. And the rule of thumb you'll hear with mycorrhizal fungi, there's 7 categories of them. And the bottom line they always tell you is that all the carbon, the reason it happens and works is the fungus draws in water and minerals and maybe other nutrients, including, say, nitrogen from the environment through its vast mycelial network with the high surface area that I described, brings that to its plant partner, and in exchange, the plant provides excess photosynthesized sugars, and that's the trade-off. And that does seem to be holding true for most types of fungi. One of the exceptions, I think one of the better exceptions is, and there's kind of two, is the ericoid mycorrhizal fungi. These are the fungi that associate with, I'm pretty sure, all ericaceous plants, all plants in the Ericaceae. And these fungi and plants often live in very acidic soils, really extreme, northern climates, heathlands, and things like this, and bogs. And the fungi, through their chemistry, help to buffer the soil pH so that nutrients don't get locked up, minerals don't become unavailable. And at the same time, when the plant's in the surrounding environment, sometimes you'll have a heathland that's just all heath pretty much. And when the plant dies, the same fungus is the one responsible for digesting, the plant right next to it or what have you, and then feeding it to this other plant. So in that case, they're actually the ones taking in the carbon and moving it and feeding the plant. The exchange is going the other way that it's not supposed to. In that case, this is another example where the ericoid mycorrhizae have been considered and called the drivers of these whole ecosystems, because without them, they are the ones completely essentially creating, in large part, the carbon cycle. Sure, there is some carbon coming in through photosynthesis, but so much of it is being cycled through the soil and all the chemistry effects via these fungi. Another good example of how it can go backwards or the wrong way is with the monotropoid mycorrhizae. And these are fungi that associate with the plants in the monotropa, the non-photosynthesizing, the pink, the white plants, ghost pipe and things. And so these plants are not photosynthesizing, yet they're surviving. They need carbon, so they must be getting all of their carbon, or the vast majority, maybe a little bit from other microbes or something, but the vast majority from their mycorrhizal partner. And this association is only formed with a small number of fungi, the monotropoid mycorrhizal fungi, monotropoid mycorrhizae. But what's curious about them, just to put a twist on it all, is those fungi need to be getting their carbon from somewhere. And so they're not able really to get it out of the soil. Rather, they are connected over, here's the ghost pipe, here's the fungus in the middle, and over here's the tree. And the tree comes down, forms what's called an ectomycorrhizal relationship. The structure looks different. All that's going on in the root fungal interaction is very different, but it's the same fungus. And then over on this other end, it's the monotropoid association. The structure is different, how it interacts with the root is different, how it looks is different, same fungus. And it's essentially a conduit and feeding and keeping these plants alive. And they frame it as, and they call it a parasitism. They say that these plants are being mycotrophic and they're feeding off the fungi. I mean, it's a way to frame it. I like to think that there's a reason this happens, that the fungi are smart enough or what have you, that as they evolved, they wouldn't have let this parasitism to occur. There are other parasites, of course, throughout nature, and maybe that's all it is. But I like to think there's something to it. And some reason they keep these interesting plants alive, and there's some other exchange. But generally, for the ectomycorrhizal mushrooms, the mushroom and truffle formers, as well as our arbuscular mycorrhizal fungi, which are some of our most critical soil fungi, they seem to be heavily, if not entirely, dependent on their plant partner for survival, primarily, especially through the carbon acquisition.
Hi, everybody. Thanks for watching. Subscribe here to get the latest from the show.
Also, be sure to check out some of the great clips and watch the full interviews right here on In Search of Soil.